My name is Thomas Burke. I'm the President and Executive Director of the OPC Foundation. Today I want to talk to you about the vision and the future of the OPC Foundation with respect to the OPC UA technology and where we are today and where we're going tomorrow. First off, the most important thing about the OPC Foundation and what we're doing is the OPC Foundation is a nonprofit international standards organization dedicated to developing the best specifications, technology, process, and certification to achieve multi-vendor, multi-platform, secure, reliable interoperability for moving data from the sensor to the enterprise. We do this with the OPC UA technology in such a way that it's a very platform-independent strategy, truly allowing multi-vendor interoperability from industrial, automation, and beyond. There's a lot of things that we do with the OPC Foundation to help people understand the technology. If you'll notice today, we have a video that basically is an idea that quickly gives you a 60-second overview of what OPC UA is all about.
What is OPC? OPC UA is an open standard that specifies information exchange for industrial communication, particularly on devices within machines, between machines, and from machines to systems in a convergence of IT and OT. It can be used with any software platform, Windows, Linux, Mac, Android, well, you get the picture. And this makes OPC UA scalable, from minimal embedded controllers to massive cloud infrastructures, even mobile devices. OPC UA is equally suited in a closed network or utilized via the internet. Don't worry though, security is baked into the protocol for access control, authentication, and encryption. Because of its flexibility, OPC UA has been widely adopted in industries like automotive, food and beverage, oil and gas, energy and utilities, packaging, building automation, and so on. So, as manufacturing moves into the Industrial Internet of Things Industry 4.0 realm, OPC UA is already poised to fulfill the requirements.
The OPC Foundation really is a very international organization. Over 50% of my membership in the foundation is actually based in Europe, and another almost 30% is in North America. But the fact is, actually, it's really spread around the world internationally. We have an organization in Scottsdale, Arizona, where my offices are at. We also have a group in Germany, China, and in Japan. And currently, we're working on forming a new organization in Korea and as well in India that really forms the technology and marketing arms of the OPC Foundation from a regional perspective. The OPC Foundation also has a very active board of directors that drives the technology and drives the vision of OPC. We have 4 very significant member companies in Europe with SAP, Beckhoff, Siemens, and Ascolab. And in the US, we have Microsoft, Honeywell, and Iconics, and we have Yokogawa in Japan. And this really controls and helps drive the foundation vision of technology. So the OPC Foundation and the OPC UA technology is specifically working to address the needs of Industry 4.0 and the Industrial Internet of Things. But if you take a look at what the Industrial Internet of Things does right now, there really isn't a whole spirit of interoperability because the Industrial Internet of Things, as it is now, is really about connectivity between disparate devices and applications. So consequently, when you use just the Industrial Internet of Things as it is today, the whole concept is you have to write a lot of special software to truly have interoperability between a lot of different devices and applications across a multitude of platforms. But with OPC UA, what we're doing deliberately is we're going to focus on the ability to standardize on the whole concept of being able to move the data and the syntax and the semantics of the data such that the Industrial Internet of Things will truly be interoperable, providing much more than just pure connectivity. One of the most significant things as we think about where OPC came from in 1995, it was all about connectivity and moving data from process control and factory automation to the first tier visualization. But when we started OPC, we recognized we've got all these legacy systems out there and the importance of bridging the gap and bringing all those things forward by unifying the OPC specifications and all those classic specifications, including data access, alarms, and events and history, such that it fits and plugs directly into the OPC UA architecture. This allows complete seamless interoperability from applications and devices that were achieved and developed in 1995 deliberately into the 2016 and beyond. When I talk about OPC, the early days of OPC Classic, and I love Microsoft, it was very tied to the Microsoft platform. Everything we did, all the OPC specifications, all the OPC technology, was deliberately built on the Microsoft COM technology. With OPC UA, we still love Microsoft, but the concept is the world has changed. It's now about multiple platforms. It's now about having the ability to have seamless interoperability independent of the operating system and platform. So I'm proud to say now with what we're doing with OPC UA, whether you're supporting iOS or Android or Microsoft or Unix, all of these different applications and devices actually work together in a seamless fashion because of the way we've structured OPC UA to be totally platform independent. In addition to that, as we move forward on this, we talk about scalability. And I talk about the importance of scalability because we're talking about really taking data and taking it from the sensors and the PLCs and the DCS systems and being able to transport that data in a seamless fashion and be able to understand that data and make it useful information as you move up into the cloud. So consequently, OPC UA is very scalable. We provide standard internet protocols that really allow the whole concept of cross-platform communication. And the idea is we've done this via a mechanism providing multiple languages and support. So we provide .NET, C, C++, and Java-based versions of the OPC UA technology to foster this interoperability accordingly. So if you think about what we've done, we guarantee interoperability, cross-platform, scalable from the sensors to the cloud. And that's a very significant thing. And as you approach the whole needs of Industry 4.0 and the industrial Internet of Things, you also have to think about the importance of security. Security is really job number one in our architecture. And as you see what we're talking about up here, we actually are very focused at securing the network traffic. We follow all the standard web standards. We didn't invent this. We essentially took the security implementation and the security architecture, and we built it into the OPC UA architecture such that all the vendors that build UA products get security, and security is agreement, and you get clients and servers to have secure, reliable connection. So we do complete encryption, we do authentication, we provide security down to the object level, allowing different applications and devices to share information in a secure fashion and be able to specify who's authorized and who's not authorized to see the data. We're very proud to know that the work we've been doing with OPC UA has actually been looked at by many organizations, including the German government and BSI, who's actually taken a look at OPC UA from an Industry 4.0 perspective and said, you know what, we really believe in OPC UA because it is the meets and exceeds all the security requirements specifically of Industry 4.0. We're also working with the other agencies in China, in Japan, and in North America, specifically addressing, guaranteeing, and making sure that OPC UA provides the best secure implementation. You'll notice on the OPC Foundation website you can find information about this. There's a complete document that talks about what BSI did in the German government, as well as other organizations and their specifications. OPC also has to focus very highly when you start thinking about the industrial Internet of Things and you start thinking about Industry 4.0 in terms of communication reliability. So now with our architecture, we guarantee that when the connection between the client and server isn't working, we have a mechanism to detect that, and more importantly, we have a mechanism to recover it, such that we ensure robust and reliable communication, because there's keep alive monitoring all the time between all the disparate applications and devices. Again, providing complete redundancy, having fast recovery in case of any communication errors between the applications and devices supporting OPC UA. Another significant benefit of OPC UA is what I call the unified data model. Now, when we started classic OPC, everything was bundled into a single set of what was known as remote procedure calls, and consequently the data and the services were very tightly bundled together. So for example, with OPC Classic, we had approximately 35 different ways of reading data, and the data was just different, but really it should have been the same thing. One of the significant things that OPC has done was basically create, with OPC UA, a unified data model. Now, the idea behind this was actually to unify and simplify all of the classic OPC constructs into a new architecture of OPC UA, where we actually were able to separate out the data from the services and the methods and the events and build a common data model, truly allowing a whole new way of doing interoperability. With classic OPC, we had lots of different ways of reading data. We had lots of different ways of subscribing and pushing out alarms and events. We had lots of different ways of reading historical data. But with OPC UA, we've concentrated on a mechanism where the services and the data and the events and the alarm information are all separated. This is the unified data model. And this is very important because we've taken this and we've actually reduced the system integration cost by really providing a common information structure allowing seamless access and information. I'm going to talk a lot more about that as we move on. So also as part of this unified object model, it really is a complex data modeling architecture we've built in. And this allows basically any OPC products to truly represent anything that they want. And the concept of this allows an application to be able to connect up to some device down here and not understanding what the device is, kind of like the USB of industrial automation. Consequently, I can plug into this thing, I can discover it, and all of a sudden, I'm going to be able, for my client, to be able to communicate to it and understand all the complex data types that that server may represent. The biggest thing is OPC UA provides a mechanism then of providing not only the data, but all the metadata behind it in synchronous atomic transaction to be able to use this. So, and the whole UA information model really defines all the modeling elements and modeling rules that are key to this architecture of OPC UA. We also provide an ability for method calls and programs to be invoked. So I can have one device be able to invoke an application and a method in another device, again allowing a mechanism for seamless interoperability. This really allows you to do things like state diagrams and be able to have applications trigger another application, and when that application finishes, report back to the device. Consequently, we've got transactional capability. So OPC UA is defining deliberately into the architecture a mechanism for a UA client to invoke devices, applications in the server, and then report back. So if you think about what we just did, again, it's about a transaction-oriented model. Again, structuring on everything we've done with metadata, now you can actually invoke applications and report back. This is a very important thing as you start thinking about the whole concept of the industrial Internet of Things and allowing applications and devices to have seamless communication between them. So is OPC UA fast? Let me tell you how fast it is. Deliberately, OPC UA has been focusing on making sure that we provide the best specifications and technology, and we validate the specification by implementing the technology, making sure that it provides feasible and exceeds the performance requirements of today and tomorrow. OPC UA is deliberately built. It's architected for speed and network performance. We can literally transfer 1 million data points a second, okay? And these aren't simple digital points, these are doubles. These are doubles that include both the value and the timestamp. It's a lot of data we can move right now with the existing OPC UA architecture of the client and server. And I haven't even talked about what we're doing next with publish subscribe. So the consequence is that with everything that we're building in and the way OPC UA has been architected, the transport underneath can continue to change. We can bind and have new applications and continue to make the performance even faster. This is a significant opportunity with the OPC UA technology. I talk about data. I talk about information. With OPC UA, we've got a strategy and architecture that allows vertical integration for seamless data transfer between the shop floor and the top floor. And what we actually do is, you can have an OPC UA client that becomes an OPC UA server, basically publishing data up the tier to the next client application. This is our vertical integration strategy. This allows the enterprise network to be able to talk directly to the plant network, except what you're talking about is at the plant network, it's data. At the enterprise network, it's truly information. This is built into the UA architecture deliberately, and again, most importantly, it's all platform independent. I don't care if it's Microsoft, Unix, Linux, Android. Everything just works together for seamless interoperability from the shop floor to the top floor. So what really is the motivation behind UA, and why did we get here? Well, you know why we got here? Very simply. There was a whole concept and need for not only platform independence, there was a need to have OPC UA and OPC technology being embedded in devices. In the old days, you had to build and have a Microsoft box in the middle that understood how to talk to the embedded device and then be able to serve up data to the client application visualization. That was wonderful, and it always worked in the case where everything was a Microsoft operating system. But many of the vendors and many of the end users really didn't like the concept of we always have to have that Windows PC in the middle being able to talk between the client and server. So consequently, with OPC UA, we came up with a solution. It's cross-platform. It's embeddable. Concept is now I can put OPC UA directly down into the PLC, again, providing a mechanism no longer needing the Windows PC in the middle, and now I can exchange data between the client application in a far more reliable fashion, moving that data and information. OPC needed to have a strategy also to address the embedded HMI. The solutions today, prior to the OPC UA technology, is that you had to have a proprietary device driver built into the architecture, or you had to have a Windows CE OPC server built into the embedded HMI, or you had to have a gateway PC in the middle that understood how to talk to the embedded HMI and then talking down to the lower level OPC server. But with OPC UA server typically comes with the device, allowing this to be a server to natively push data out, don't need a Windows PC anymore. Now the OPC UA compliant comes built into the HMI, and guess what we've got? You've got an embedded PLC being able to talk to embedded HMI using the OPC UA technology. Truly, this provides a very significant, high-performance, plug-and-play architecture, allowing an embedded HMI to be able to talk to a variety and multitude of embedded PLCs and embedded devices overall, supporting the OPC UA technology. Significant thing we also really do is all about device-to-device communication. This concept allows you to have PLCs and machines to be able to talk horizontally in a seamless fashion using the OPC UA technology. In the old days, you had to have very project-specific, implementations to be able to do this. You had to write a lot of custom software, or you had to have a serial connection between these machines. But in the case of OPC UA, both of these devices that seamlessly are able to communicate together are actually OPC UA servers, and they can actually talk together, essentially sharing the OPC UA message infrastructure and all the data directly on the wire. Examples are the partnership we have with PLC Open, where we've actually created function blocks that allows a state diagram and essentially transactions being operated, sharing data and information in a very easy fashion between devices. If you think about what OPC really does, It's about collaboration. I talked a little bit about information modeling and the complex data model. And the concept is we have a lot of organizations that essentially to take their information model and map it into an OPC UA namespace and take advantage of the rich set of secure, reliable services to take that information and be able to generically communicate it across disparate applications and devices. They're very important organizations that we're working with across oil and gas, pharmaceuticals, security, machine tools, okay? And the list goes on as we start thinking about the whole concept of information integration and moving data and information from sensors directly to the cloud. We have partnerships with all the field bus organizations deliberately, where the field bus organizations are standardizing on using OPC UA as their infrastructure necessary to take their information and their data and be able to have connectivity to the cloud. Recently, we've done some very important things with Microsoft and SAP. Microsoft is standardized on OPC UA as the interface to the Azure cloud. Microsoft also, and additionally, has built in OPC UA deliberately into the Windows 10 IoT core, again allowing an easy way for vendors that want to build embedded devices with Windows 10 IoT core to have OPC UA natively embedded in their device. There are many other vendors that are doing a lot of work very specifically with the OPC UA technology, essentially to address the embedded market, essentially to address cloud computing with stops in between. So if you think about what OPC UA all is about, and the value proposition of what we're trying to do is, it's about security, it's about reliability, it's about interoperability, it's about modeling data and behavior and allowing a seamless way of having plug-and-play data and information being able to be communicated in a seamless fashion across multiple platforms. It's an international organization. OPC is very open. Our specifications are available to non-members, are available to technologies available as open source, and our certification program we've recently announced is also available to non-members. This again is the whole spirit of cooperation and collaboration that OPC is focused on. We're platform independent, we're network independent. We will have an architecture that allows timeless durability. Consequently, you can take applications and devices in 1995 and they'll work in 2016 and beyond because we've guaranteed seamless interoperability even though the technology changes. So there's a lot of things we're doing with OPC UA. We're going to talk a lot about the future. We were client server, we still support client server. Now we've built in the whole publish subscribe. OPC UA transports include AMQP, MQTT, DDS as native transport for moving data and information horizontally and vertically in the world. So with that, I'd like to end this and talk about, if you want for more information, please go to the OPC Foundation website, www.opcfoundation.org, to learn more about OPC UA and what it can do for you.